Okay, now let's look at examples. The question is d2y dx2 minus 8 dy dx plus 16y equals to 2x square minus 1. Firstly, please identify whether the given question is the first order differential equation or second order differential equation. Okay, in this question, your highest order of the differential equation is the d2y dx2, which is the second order. So, this is the question for the second order differential equation. Alright, next, for second order differential equation, okay, we have homogeneous and non-homogeneous second order differential equation. So, in this question, your Rx is not equals to 0. Okay, so here, your Rx is not equals to 0, meaning it is the non-homogeneous second order differential equation. So to solve the non-homogeneous second order differential equation, firstly you will start with write in the form of prime. So we have y double prime minus 8y prime plus 16y equals to 2x square minus 1. Okay, so we write it as the first equation, or it is the original equation. Alright, so your first step is find yg. Okay, to find yg, we will assume your y double prime minus 8y prime plus 16y equals to 0. Okay, alright, continue. We have to find the characteristic equation. Okay, your characteristic equation will be m square minus 8m plus 16 equals to 0. Then continue. Factorize and you will get your m1 is 4 and m2 is also 4. Meaning here you have two equal roots. Okay, so for two equal roots, your y will be c1emx plus c2xemx. Meaning your yg will be c1e for x plus c2xe for x. Okay, continue. Next step is you have to find yp. Okay, so to find yp, firstly identify your rx. So your rx is 2x square minus 1. Rx is your right hand side. Okay, we have 2x square minus 1. Then identify what is the type of your function. So 2x square plus 1 is the quadratic function. Right? Then what will be your yp? Yes, your yp will be ax square plus bx plus c. Okay, next you will differentiate your yp. Differentiate as usual, you will get 2ax plus b. Okay, then differentiate again your yp prime to get your yp double prime, which is 2a. Okay, next step, substitute yp prime and yp double prime into your original equation, which is 1. Okay, so this is your original equation. So when you substitute, it will be 2a minus 8 2ax plus b plus 16 ax square plus bx plus c equals to 2x square minus 1. Then simplify your left hand side. Okay. When you simplify, you will collect all the constant for each term. Meaning, you will collect the constant for x square and then collect the constant for x and also for the constant. Okay, x power 0. Then you will use comparing coefficient of left hand side and right hand side. Remember, your target is you want to find your a, b and c. So using comparing coefficient, for x square we have 16a equals to 2. So your a will be equals to 1 over 8. Alright, continue. Comparing coefficient for x, you will get your answer for b will be equals to 1 over 8. And next, comparing coefficient for the constant or for x power 0. Okay, next you will get your answer is c equals to negative 1 over 64. And lastly, substitute the value of a, b and c into your yp. Okay, substitute in your yp and you will get now your yp will be equals to 1 over 8x squared plus 1 over 8x minus 1 over 64. Okay, and your final solution y will be equals to yg plus yp, which is equals to c1e for x plus c2x e for x plus 1 over 8x squared plus 1 over 8x minus 1 over 64. Okay, now let's look at example B. The question is d2y dx2 minus dy dx minus 6y equals to 6x plus 1. So this is a non-homogeneous second order differential equation. Right? So the first step is you will write your differential equation in the form of prime. Okay. So it will be y double prime minus y prime minus 6y equals to 6x plus 1. Okay, first step, you have to find yg. To find yg, we will assume y double prime minus y prime minus 6y equals to 0. Okay, then you have to write the characteristic equation. Okay, your characteristic equation will be m square minus m minus 6 equals to 0. And when you solve, you will get your m1 will be equals to negative 2 and your m2 will be equals to 3. So this is two distinct roots, two different roots. Alright, so for two different roots, your yg will be in the form of c1e m1x plus c2e m2x. So your yg will be c1e negative 2x plus c2e 3x. Okay, second step, you have to find yp. Okay, so firstly, your trial solution. So what is your Rx? Your Rx is 6x plus 1. So for this example, it will be easier compared from the first one because your Rx is in the form of a linear equation. Right? Okay, next, the general form of your linear equation will be your yp. So your yp will be ax plus b. So that is the general form of your linear equation. So this is linear. Alright, continue, differentiate your yp to get your yp prime. So yp prime will be just a and your yp double prime will be 0. Okay, differentiate constant will be 0. Next, substitute your yp prime and yp double prime into your original question. Okay, so we will have 0 minus a minus 6 ax plus b equals to 6x plus 1. And then simplify by collect the constant for each terms, that is collect constant for x and collect the constant for your x power 0. And next you will use comparing coefficients. So compare coefficients, you will get for x, your a will be negative 1, and for the constant, you will get the value of b. Okay, and the value of b will be 0. Okay, remember your target is you want to find the value of a and b so that you can get what is your yp. So your yp is ax plus b, and now you will have your yp is negative x. Your final answer will be y equals to yg plus yp, which is equals to c1e negative 2x plus c2e 3x minus x. Okay, example C, d2y dx2 minus dy dx plus 6y equals to e negative x. So you will write in the form of prime, y double prime minus y prime plus 6y equals to e negative x. First steps, we will find yg. Okay, to find yg, you will write your y double prime minus y prime plus 6y equals to 0. And you will start with the characteristic equation. It will be m square minus m plus 6 equals to 0. And when you solve using calculator, it will be in the form of complex number. Okay, or you can use formula. Alright, so this is your m. Your m will be 1 over 2 plus minus sec 23 over 2i. So your alpha will be 1 over 2 and your beta will be sec 23 over 2. Okay, next step, if you have your m is complex roots, then your yg will be in the form of eax, e alpha x, c1 cos beta x plus c2 sin beta x. So your yg will be e1 over 2x times c1 cos sec 23 over 2x plus c2 sin sec 23 over 2x. Okay, so next step, find yp. Okay, your Rx now is e negative x. It is in the form of exponential function. So the general form of an exponential function will be, so your yp is e negative x. Next, just differentiate your yp to get your yp prime. You will get it is negative a in negative x, and then differentiate again, you will get a in negative x. Next step, substitute your yp prime and yp double prime into number 1, equation number 1, or the original equation. Okay, y double prime minus y prime plus 6y equals to e negative x. Then when you substitute, you will get a e negative x minus negative a e negative x plus 6 a e negative x equals to e negative x. Okay, simplify. Next, simplify, you will get okay, a e negative x plus a e negative x plus 6 a e negative x, then lastly you will get 8 a e negative x equals to e negative x, meaning your a will be equals to 1 over 8. Okay, so substitute the value of a into your yp, and your yp will be 1 over 8 e negative x. Your final solution will be y equals to yg plus yp, which is equals to e1 over 2x c1 cos sec 23 over 2x plus c2 sine sec 23 over 2x plus 1 over 8 e negative x.